Determine the values of b and c such that the function g of x equals x squared minus 9 over the absolute value of x minus 3 for x is less than 3, b for x equals 3, and x squared plus cx for x is greater than 3, at the x-coordinate x equals 3 will be continuous. The definition of continuity is the limit as x approaches a from both sides of g of x equals g of a. We are specifically looking at the x-coordinate of 3, so we have the limit as x approaches 3 from both sides of g of x equals g of 3. Let's start with the two-sided limit as x approaches 3 from both sides of g of x. G of x here is a split expression function, and it splits right at the x-coordinate of 3, so the two-sided limit has to be evaluated from each side separately. So we will have the left-sided limit and the right-sided limit. Let's start with the left-sided limit. The left side of 3 is less than 3, and that means we'll use this expression for the g of x. So we have the limit as x approaches 3 from the left side of x squared minus 9 over the absolute value of x minus 3. We can start by plugging a 3 in for each of the x's. That will give us 3 squared minus 9 over the absolute value of 3 minus 3. 3 squared is 9. Minus 9 will be a 0 over the absolute value of 3 minus 3 will be a 0. Since we resulted in a 0 inside the absolute value symbols, we will need to look closer at which side we're approaching from here. We have the limit as x approaches 3 from the left side of x squared minus 9 over the absolute value of x minus 3. The left side of 3 means less positive than 3, like 2.99. And if we were to put a number that's less than 3 but near 3 in for x in the absolute value, like say 2.99, and subtract 3 from it, that will give us a negative number. The absolute value ensures that what comes out of there is positive, and it does that by taking the negative of it if it already is a negative. So we can remove the absolute value symbols and replace them with parentheses if we put a negative in front of it, so that the double negative will make positive. Now in the numerator we have a difference of squares that will factor into x plus 3 and x minus 3. And the x minus 3's can now cancel, removing the 0 over 0 indeterminate form. This will leave behind the limit as x approaches 3 from the left of x plus 3 over negative 1. We can now try plugging a 3 in for the remaining x's. That will give us 3 plus 3 over negative 1. 3 plus 3 is 6 over negative 1, result in negative 6. Now we can look at the right side limit. The right side of 3 is greater than 3, and that means from the split expression function we use that expression for g of x. So we have the limit as x approaches 3 from the right side of x squared plus c times x. Next thing to do is try plugging a 3 in for each of the x's, and that will give us 3 squared plus c times 3. 3 squared is 9, and c times 3 can be called 3c. In order for the two-sided limit to exist, the two one-sided limits have to match each other. So at the very least we know that 9 plus 3c does have to equal to negative 6. Since there's only one variable, we can solve for the c here by subtracting 9 from both sides, and 3c will then equal negative 15, and divide by 3, and c will come out to a negative 5. But we also need this to equal to g of 3. This only gives us the two-sided limit being the same value from each side. We want to compare it to g of 3. Now g of 3, looking at the split expression function, is right when we're at 3, and that's a value of b. And that value of b does have to match the results of both of the one-sided limits. So we can put that up here and equate it to those. And according to that, it looks like b equals to -6.